so much time to elute and measure one sample, it's not logistically feasible to have everybody work in independent pairs and do everything as a pair, because it takes so much time to run the samples. And so what we're going to do is we divide up within a lab section that there'll be groups of people working in larger groups than just a pair. And we're going to have you come together as a lab group within the section, and it'll essentially be the same kind of divide and conquer, but there'll be sort of division of some of the labors, but there'll be a larger group decision about how to design the experiment, what samples, how to process the samples, how to prepare the standards, what standards prepare, and so on. On the subsequent pages of the instructions for Lab 2, because I think there's 3 pages, 2 or 3, we give you some suggestions about how to go about that, right? But it's going to require a little bit more teamwork than just 2 people working together. The challenge is that everybody, as always, is responsible for everything, right? So even though you're not doing something, you're still responsible for it. And that means that when people are making decisions about doing things, it should be a group decision, whatever group size it ends up being. Maybe it's divided in half for the section. And everybody should know what everybody else is doing and vet that. And I want to ensure that they're doing something that I think is the right way to go, and I trust it. This is probably the one lab, so this is for sure one lab where it's extremely challenging to go through the 4 lab times and come out with all the data you want to get. Okay? It's challenging. Sometimes things don't cooperate. So when you come into lab on Monday or Tuesday, you will have printed this out and you will have read through this, and you will have become prepared of knowing what the goal is going to be. I already showed this. This is the instrument. I'm not going to belabor this. For these instruments, and for most instruments, I always encourage students and people learning to use the instrument first time to initially ask one question. And the first question is, what should I not do so I don't break it? So then we're not screwed. And in this case, the one thing that you should not do that will break it is if you'll be having these small little tuberculin, like the 1 mil syringes that are used to load the sample on. And this is a lure lock, a twist lock for the syringe body. And you will put the syringe here, lock it in, and then you'll slowly inject your sample into the sample loop. Okay? And then you will push a button, and then the solenoid will switch and start pumping mobile phase through the sample loop and flush it out into the column and so forth. And if you broke that, then we would have no way, say we, but of course it's you, would have no way to inject samples onto the instrument. And we do have some spares for some of the parts of this, but that's limited. And it takes a while to order parts, so if something got broken, it could compromise our ability. So you want to be very careful. And because this thing's on the bench and this syringe is sticking out, it's very easy when all the students are there talking and stuff to walk by and bump it and knock it and break it. Okay? So the TAs will reiterate that. Careful, when you walk by. So that's one thing that's a problem. The other is that in any kind of an instrument where you're dealing with high pressure and the pressure is high, 1,000 or 1,500 psi, because of how the column's packed, if you load a sample onto that has any floaties in it, and that means that's particulates that you can see with your eye, or maybe not even see with your eye, it will clog the column, the pressure will skyrocket, and the instrument will shut down. And that happened last year. It doesn't happen all the time, but it happened last year. And so all the samples that we'll give you to run will be samples that have already been filtered through a 0.22 micron filter, so there's no particulates there to clog the column. In this instrument, there's what's called an analytical column. This is a 25 centimeter one, I think it is. And then just upstream that is a small little guard column. It's just made out of the same material, but that guard column is there, so when people do load something on there and it clogs the guard column. And we can change that. We have extras of those. The analytical columns, typically they run anywhere from $400 to $1,000 per column, and they have a finite lifespan. And so a bunch of stuff goes on that column, it's a problem. So that's the one thing that we'll be really careful about. The way this thing works is that you have a pump. And somewhere on here is the sample loop injector. I don't see where is it. Okay, here we go. The sample gets injected. It goes into this really fancy machine solenoid that has all these ports that come in, and on that solenoid is screwed in a sample loop, and that's a piece of tubing with an exact length, so the volume of that tubing is fixed at exactly the the certified volume. In your case, I think it's 25 microliters. So you'll take a sample of the syringe in it that's got a mil or whatever, and you'll pump it, that whole mil through, and it'll flush through, and it'll fill the sample loop with your sample, and the rest will drain out into the drain, in the waste. And then you'll push a button, and the solenoid will switch, and it'll, mobile phase will go through that sample line and load that 25 microliters exactly of sample onto the column, which is this way. And it'll load through the guard column, to the analytical column, then it goes through an ion suppressor, we'll talk about that is, and finally to the detector. Okay. So the two things that go into it to be careful on are, one, don't bump into the thing and break the syringe fitting, and the other is be mindful that if I see any precipitates or any floaties in a sample, I cannot inject that because it will ruin it for everybody. It'll have everybody upset. So you'll come in on Monday or Tuesday, have read that prepared, and then we'll start, and on Monday or Tuesday will be the demo for the TAs about how to get this going and talk about the design.
Are you going to have like recommended readings of the first lab?
Yes, chapter 26. You mean?
Like for like experimentation, like experimental purposes?
Oh, you mean like literature?
Yeah.
No. There is, well, let me take that back. I think on the lab there are some recommended readings. For you to get familiar with, say, it's anion exchange, and this is actually, thanks for bringing that up. This is anion exchange chromatography. And aside from reading in the book, chapter 26, to get the basics of understanding for liquid chromatography, knowing that it's anion chromatography, there are lots of references that are available to you. I am happy to provide some of those to you, but I think now, as we move forward, the expectation is that I'm going to look and understand a little bit about this on my own, about how this is utilized. And I would encourage all of you to get on the internet and PubMed or whatever peer-reviewed journal source database you prefer, not Wikipedia, that you're going to look at some of those references and say, get a sense of how this technology is used, right? We're going to tell you exactly what to do. Unlike Lab 1, and a little bit unlike Lab 3, here we're essentially telling you how we want you to go about it. So there's not the latitude that you had before. Here the latitude is in designing how am I going to do this in the time I have, get all the things I need, as opposed to the method I use. Okay, all right.